Let us do an example of conservation momentum in collisions. So let's take a classic one. So if we have two railway wagons, if a 15,000 kg wagon moving at 4 meters per second hits a stationary 20,000 kg wagon and they join together, how fast do they move off? How fast do they move off? Okay, so here's the before picture. This is moving. It's doing 4 meters per second. It weighs, I don't know, 15,000 we said up there. 15,000 kg. This one's doing 0 meters per second. And this one weighs 20,000 kgs. And then the after, they join together, they're fused, and they're moving off with a common velocity. V equals question mark, and their mass equals 15 plus 20,000 kgs. So it's going to weigh 35,000 kgs. So how do we work this out? Well, we're pretty much written down what we know. So what we're going to use here is conservation of momentum. So from PF equals PI. So let's work out what the initial momentum is. The initial momentum, PI, is going to equal P1 plus P2, so mass 1, V1, plus mass 2, V2, which is equal to 15,000 kgs, 4 meters per second, plus 20,000 kgs at 0 meters per second, equals 60,000 kg meters per second. But we also know PF equals PI, which is equal to PF equals mass final, velocity final. So if I rearrange this equation for velocity final is going to equal, well, we divide both sides by mass final, the initial momentum over the velocity, over the mass, which is equal to 60,000 kg meters per second divided by 35,000 kgs, because that's the mass of the two wagons were added together, equals, well, we use a calculator at this point, so 60,000 divided by 35,000 equals 1.714 meters per second. So what happens is wagon 1, wagon 1 coming along, hits wagon 2, and then they move off together. Let's do another example. We've got two objects in motion. So two cars, car 1, M1 equals 1500 kg, and M2 equals 2000 kgs, collide head on. This is on Mythbusters, so nobody's hurt. There's nobody in the class. We're just doing remote control cars for an example. Collide head on. if V1 equals, I don't know, 10 meters per second, and V2, sorry, that's 1, isn't it? V2 equals, well, it's going to be, let's say 15 meters per second, but because it's head on, it's going in the opposite direction, so it's going to be 15 meters per second. If they move off together, what is their final velocity? What is their combined velocity? So, again we have car 1 doing this, car 2, this one's going that way, that one's going that way, 10 meters per second, 15 meters per second, 1500 kgs, 2000 kgs. So what we have to do is, again, we're going to use conservation momentum. P final equals P initial. So what's P initial? P initial is equal to P1 plus P2. It's equal to mass 1, velocity 1 plus mass 2. So mass 1, velocity 1 times mass 2, velocity 2, which is equal to 1500 kgs times 10 meters per second plus 2000 kgs times, and this is the big one, negative 15 meters per second, and it's calculate the time, so 15,000 plus 2,000 times negative 15 equals, so there's actually a negative 15,000 kgs meters per second impulse. So what this means is that the actual combined momentum of this is actually going that way. The initial momentum, we add it all up, is actually going that way. Okay, so what's the final momentum going to be? So P final equals P initial, which is equal to mass final, velocity final. Okay, so let's rearrange that. So V final equals P initial over mass final equals, well, negative 15,000 kg per second divided by mass final is going to be again 1500 plus 2000 kg equals, sorry, kg divided by 3,500 equals negative 4.286 meters per second. So what has happened here is, as the cars come together, the crunch, the heavy one then pushes the light one back. And as a rule, because this has got the greatest change in velocity, because it was going that way, now it's going that way, as a rule, in an accident, white car always loses. Damn it, I'm going to have to get a heavier car.